and good morning, everyone. I'd like to thank the organizers for the opportunity to come here today to present. And indeed, this talk is really about what is the role of the cloud in the future of robotics. We actually believe that the cloud is going to prove to be one of the more powerful tools that developers have, not only just to build a robot application, but to manage the robot once it's in production, but to also build the end-to-end application in which that robot is operating in. Now, I know many of you are probably thinking about, hey, wait, what about latency? This is an interesting area. We have a tailwind here. Edge computing is becoming very important for a lot of cloud service providers. Last year at reInvent, we announced a number of offerings to move our services closer to the source, closer to the edge. You see connectivity solutions are increasing, 5G and other offerings that basically allow you to have constant connectivity with high bandwidth to the edge. The edge is really an interesting place, and over the next few years, I think that landscape is going to change, so watch this space carefully. But issues of latency actually are going to become less important, less concerning. And is the clicker working? There we go. All right, so we started this whole project about 2 years ago, almost to the date. We had been looking at how difficult it was to actually build a robot application. We're trying to scratch our heads on what role would the cloud play. Honestly, we looked at the same challenges that web services developers were facing when we started AWS, and we saw a lot of strong similarities. The diversity of skills that one has to bring, the challenges of building an app, deploying it, and managing it. In fact, if you just think about, if I wanted to build an autonomous robot today, I'd probably have to have some intelligence on it. Well, there are cloud services for machine learning services. Why not actually have that processing taking place in the cloud? And again, latency, don't let that get in your way of thinking. That's going to change. Developers have to do a lot of iterative development when they're first testing their robot, building it. Wouldn't it be cool if they could actually have simulation and be able to test their ROS nodes or their packages and iterate quickly in simulation? What if they could actually take a log of sensors and replay it to see if the application performance had improved or at least stayed the same? We also noticed configuration management's hard. There was a talk earlier today about discussion about getting education. Try setting up a classroom of 50 people and everybody gets the same development environment. So we thought, what could a cloud IDE actually work? Side note, talk over coffee. No, it really doesn't. Developers want to use their laptops. But that being said, it's good for cloud IDEs are good for education, for workshops, and we're looking at containers now to allow developers to work on their laptop, but we did do a cloud IDE. Limited hardware testing. What if we could actually have hardware in the loop testing where we had hardware in the lab and developers could actually test it, or at least high fidelity simulations as a service? And then deployment and updates. I walked the halls of CES 2 years ago talking to startups doing robotics apps, asked how they updated their robot. I was hearing horror stories of USB drives when my Kindle actually updates much more eloquently than that, and Teslas do as well. So over-the-air update and management of a robot once it's in production. This is what motivated why we're doing what we're doing, as well as the fact we're using ROS internally. I can talk about that later. But you know, there's no magic. There's nothing really different about robotics application development. You have to design and test and develop the software. You go test and verify, then deploy and update. We've tried to build components in AWS RoboMaker to support the development, testing, and deployment and management of robots. I'm going to talk about these pieces in the context of how customers are using it today to hopefully illustrate what we've done. Yes, we made a bet on ROS and Gazebo. We had a lot of robot experts in our company who have points of view about what might make a good framework, but you can't ignore the open source community, the contributions, the education pipeline, and there's strong evidence for the number of companies that have successfully built and launched on ROS. That was too compelling for us not to want to build on top of first, as well as starting with Gazebo as well. But in the fullness of time, we will give our customers choices for different simulators, but this is where our foundation is here today. We actually started a conversation with Brian Gerke at Open Robotics about forming a technical steering committee for ROS2. We saw the promise in that. We initiated with Brian. Other companies joined the technical steering committee for ROS2. Everyone is contributing a developer and some degree of funds to help ROS2. I think everyone here in the room probably should know, I mean, the big core difference in ROS2 between ROS1 is the introduction of the ROS middleware, RMW, and DDS. This gives, and again, DDS, there's open source versions, there's commercial, there's military grade versions. This addresses a lot of the reliability, durability, and performance issues of ROS2 core. And my team, I have a team down at Sunnyvale, actually has a number of developers, we don't talk numbers, but actively contributing to ROS-2. Some of the things that my team has contributed is a quality of service features for ROS-2, for QoS, for message liveliness, timeliness, time to be delivered. We've built cross-compilation tools to allow you to compile for different target runtimes. We are owning the ROS-2, ROS-Bag 2, splitting and compression for the upcoming release of ROS-2. The ROS-2 launch sandboxing extension, and what that allows you to do is if there's packages you don't trust, you can actually launch them in its own sandbox and limit the resources you give to it, while your trusted version of ROS will have its set resources off to the side, and you can actually monitor that sandbox as your robot's running. If it starts to consume too many resources, you can actually drain the resources and shut it off, should that package that you pulled in turn out to be a bad actor. A number of open source examples I'll talk about later. And probably the one I'm most proud of is that the build farm for ROS-2 runs on AWS. And my team actually took modern code analysis tools and put that into the build farm for memory leaks, threads, pointer exceptions. So it's run nightly, testing the quality of ROS-2 core to ensure there's no degradation. This is something I hope other package managers will actually start to adopt, is putting these kind of integrity checks in their packages as well, so it ensures that it stays at high performance. So you can start up our Cloud IDE. We let you choose from ROS-1 kinetic, ROS-1 melodic, ROS-2 dashing. We have ROS packages that wrap our AWS services. I do not want robotics developers to have to go read AWS manuals. What they should see, however, is ROS nodes that they understand how to use for like S3. If you want scalable, ridiculously cheap storage, you have a ROS node that you can actually stream data to, and actually that gets uploaded into AWS. And these nodes, they encrypt the data, they maintain a secure encrypted connection to the cloud with rotating security credential keys, all set up for you automatically. We have a ROS node for CloudWatch. If you want to get the logs off of your robot, you just send it to this ROS node, and they start appearing on a dashboard, and they're archived in the cloud for you. Metrics, like where the heck is my robot, what's the power battery level, you can stream metrics up to the cloud. Amazon Recognition is a machine learning service, and together with Kinesis Video, you can stream video to the cloud, run it through Recognition. It's a deep learning model. It tells you what it's seeing in it. And Amazon Lex and Amazon Poly, which means you can now talk to your robot, and your robot can in turn talk back to you. Let me just look at one of those. I don't want to spend much time on all the other ones. This is Kinesis Video. If you've seen Amazon Go stores where you just walk in, you shop, you grab what you want, and you walk out, and you just build, that's all running on Kinesis Video. It's streaming millions of video feeds in every day. And you can send that video to SageMakers, where you can build a machine learning model to process the video. Amazon Recognition Video does that automatically, but you can build your own. You can actually record the video. You can do custom processing of the video in real time. And we've also got a marketplace of apps that you can choose from to actually process that video as it's coming through streaming through the cloud. This is one of my customers, Woodside. They have a ground mobility robot where they do an inspection of their facility, and they have a number of tasks that this robot will do, but they can stream that video, the video-like data like LiDAR and radar up to the cloud and build the dashboard that their operator can select any one of the robots they're patrolling and actually see the video coming off of it. They can process that video. They can archive and store the video, which they do, because sometimes they're asked why we didn't do something on a certain day. They can go back and say, well, that's why, because we had an obstruction. And they can send this robot in very adverse conditions and get that data streaming off of it. This is a very hot environment that it's going to go operating in. But you get the sense. And again, why does that processing have to take place on the robot? It doesn't. Does it make sense to record and get the data off later? No, you want it in real time. And they didn't have to write any code to get that. It's just taking advantage of this. So that's what I mean about the power of these cloud services that you have access to without having to put hardware or processing on the robot until it makes sense. In the interest of time, I'll move on. But another area that we really were attracted to is how do you test and verify your code? And there's no single simple use case for simulation. And this is something that was kind of struck us. You want to simulate your robot operating in the environment. You might want to test your app in a range of conditions to make sure it performs correctly and actually use it to drive optimizations. So we offer simulation as a service with our service. We are hosting Gazebo. We offer some pre-built 3D worlds out of the box, or you can actually bring your own for your own facility. You can spin up simulation on demand. You can run multiple simulations in parallel. We do the provisioning for you. There's nothing for you to have to worry about. And it's actually pay as you go. If your simulation is really we're charging by how much CPU and memory you actually use on your sim. Simple sims are cheap More complex ones, the price goes up with it. Okay, I think everyone knows Gazebo here. I've seen this. We have interactive tools. You can actually, as you're developing, you can see your application. In this case, it's a drone program running. You can use the tools that are associated with Gazebo to see the data coming off of any one of the sensors running on your robot. We added a feature about 3 months ago, log-based sim. You can actually give us the timestamp data feed for any one of the sensors on the robot, and we'll actually run that through in simulation, again, for redo testing to see if your robot's going to perform better. We're adding other features to simulation as well, which I'll talk about later. And as I mentioned, you can actually run these in parallel. So you can give us a single app. You can give us dozens of worlds to run your app in, and we will run it in batch. We actually just released a batch API. And you can turn the rendering and visualization off. Why? You can actually set CloudWatch metrics and alarms saying, hey, I actually want to see if there's any collisions in this simulation. I want to check the battery didn't go below a certain level. You can set all these conditions associated with each one of the sims. We'll run the sim. We'll give you a dashboard. You can look to see any of what sim violated the condition and what condition did it violate. And then we have the logs in S3 so you can see your ROS logs to see exactly where your application went pear-shaped. iRobot was one of our first customers. They talked to us. They were using simulation. It took them on the order of 22 days to actually test before they'd allow the application update to be pushed out to their robots in production. They wanted to get a lot more test coverage. They had a lot more edge cases that they wanted to verify, and they wanted to do it regularly because they were seeing bad code get put into the build, and other developers are picking it up and propagating it. But it was too expensive. I mean, they already had a couple of key engineers running this for them. So we worked with them to integrate RoboMaker simulation into their CI/CD pipeline. Every time a developer attempts to check in code, they spin up simulations. So basically, the houses, they created more simulations for more edge cases. One of the cases they really want to get is they call it the robot kidnap, where somebody will pick up the Roomba, walk it across the room, and drop it somewhere else. And it has to make sure it localizes and finds its position, knows where its base is, and can get back there. Chris Kruger and I presented a talk, or Chris did, I should say, one of my colleagues at reInvent this last November. They're running at least 5,000 missions or simulations a month. They're gating submissions into their code repository. It's actually catching issues that would have gone out to production robots. They believe and know they have a higher quality mainline, and their developers actually want more, and it has scaled up considerably since then. So again, this is a killer use case that we see. I'd love to talk to you more if you think this would be something of use to you. Also, we've also found multi-robot simulation as a use case that customers have been approaching us for. They want to simulate multiple environments operating, multiple robots operating within the same environment. They want to connect these simulations together. So even though behind the scenes we're actually running each robot in its own simulation, we can actually present a unified view of the room where all the simulations robots are working in lockstep. One of the customers we worked with to actually understand the challenge here was Bastion. We talked about this at reInvent this last November as well. They wanted to orchestrate, their solution orchestrates a fleet of robots. They wanted to actually test many more robots than they're actually able to physically do in their test labs. So we worked with them to get RoboMaker to scale this up, and we're able to scale it up to 35 robots running simultaneously in the same simulation. So you can actually see the dynamics of your apps and how your robots are going to interact with each other. And what we've done here behind the scenes is we use a service called Lambda. When you say run, we start up a Lambda function to fire up the simulators. Each one's running on its own instance in my simulation fleet. We're actually using the ROS bridge to communicate information between the different simulations so they can get information about where each other's at. And then we actually aggregate that into a single simulation view. So it looks to the user like you're running a single simulation. Behind the scenes, we're running multiple Gazebo instances to actually make all this come together. I've got my email address here. If you have a multi-robot simulation use case that I could learn from, I'd like to hear from you. We're actually trying, what I just showed you here is something that we can do with some duct tape and baling wire. We're going to turn it into a first-class feature, but we want to talk to customers about what they want before we actually launch this later this year. But we do have a number of customers we're working with here right now on multi-robot sim. Simulation for actually programming a robot. We're seeing a big uptake and interest in using simulation and reinforcement learning for programming robot navigation, manipulation. And again, this is where actually running multiple simulations comes in handy. 2 years ago, we launched AWS Deep Racer. That's a ROS-based RC car. We actually announced a new one that's going to be coming out later this year that has LiDAR and multi-sense depth cameras, and we're going to expose all the ROS nodes on it. But what people didn't know is when you go to these deep racer events, you're actually just writing the reward function. And what's going on behind the scenes is that the car is actually running in simulation on Gazebo multiple racetracks to generalize the model. And again, this is where we're running dozens of simulations in parallel. And periodically, the car's making mistakes. That's what reinforcement learning is all about. Gather the mistakes, build a new model, push it back out and try again. But we're doing this in parallel. We're running dozens of these car simulations. We're gathering all the errors. We're using SageMaker to retrain the model using the aggregated errors across all sims. And then with our fleet management, when you're finally ready for it, this process will go on. When you're finally ready, you can actually then deploy the app to a physical car. This is kind of pathetic still. It's still early for this one. The people who are actually winning these contests are getting it down to 6 seconds. You can see this car still has a little ways to go in its learning process. Not a line of code is written, however, for the navigation of this robot. So again, another example of where other machine learning services actually can come in. I have one customer that's actually has a drone that they've actually put out on different oil rigs, going back to the simulation you saw earlier. And they have a list of machine learning models. And depending on the business question that they're asking, they can actually use our over-the-air to actually push a new machine learning model onto the drone and then have it do its survey of the oil rig. And if they get more data of conditions that they want to detect, they don't have to bring the drone back into the office. They can actually use our machine learning service, SageMaker, retrain the model, and again, push it back out. They can do simulation to ensure it's going to catch the conditions, to ensure it's going to work. But this is where you start to see a lot of icons up there. Those are other AWS services that build the solution. That's what I mean by the power of the cloud to help build end-to-end solutions. We've been contributing a lot to ROS-I as a team. We're about to turn our attention over to contributing more to simulation, in particular enhancing Gazebo with features that the community wants. If you or a developer in your office would have informed feedback to give us on what we should think about adding to Gazebo, I'd love it if you would take our little survey and please send us your feedback. We're actually going to make a push in enhancing Gazebo with the community, with Open Robotics this year, and some more of my engineers are going to be contributing to this. So again, simulation is such a valuable tool. All right. So another aspect of RoboMaker is our fleet management. Simply put, enterprises need more control over their robots, not only to update the application that's on them, but to also manage them once they're put into production. So we've actually added features to our fleet management. We've had customers come at us and say, hey, I am currently managing 6 autonomous robots in my facility. Each one comes with its own pane of glass. Can you give me a single pane of glass to monitor, control, see where they're at, debug, and connect to? So we've been pushing on this with the RoboMaker in our fleet management facility or feature. You register your robot into a fleet so that we know about it. It's basically an IP address, an addressable entity out there. You may decide to organize your robots by what building they're in or what their purpose is. But now we have an index of them. When you're ready to deploy your application to a robot, you can actually choose the fleet, choose the application, press update. You can tell us what percentage of your robots should be updating at the same time, and we'll monitor that to ensure we don't go above that percentage. You can specify if the app update fails above this percentage, roll the whole dang thing back. Something must have been wrong with it. We've also added conditional over-the-air updates. You can write all the conditions that your robot must satisfy, such as power level, is it idle, anything. You can specify conditions, and we will check the robot to make sure it's in a good state before we attempt to do the update. We're adding features later this year for fleet monitoring and alerting. If something's going wrong with your robot, you'll be able to see it in our fleet management console, and then actually also be able to do rollbacks. So let's say the deployment was successful, but you're hearing performance issues. Just go back and say, roll this thing back to the previous version. This is one of my partners over in Japan. Their code or their service is going to appear in our marketplace shortly. They've got a really cool low latency bidirectional data streaming protocol. Basically, you can connect to a robot. You can get just about any kind of data off of the robot, video, telemetry, other information. You can take control of the robot interactively if there's a robot that's having issues with their product. So basically, you get telemetry, data acquisition, teleoperation. You can tell where that data, where you want that data to go off of the robot. This is a demonstration that we showed earlier this year over in Japan, which is hence why the Japanese writing all through it. What you're seeing is basically they've got a controller. This is all running on ROS-I. They have got a controller where basically they're issuing commands. Not only is it being directed to the robot in the real world, but also to Gazebo, just trying to show the fidelity of the two with extremely low latency that can actually see what the robot's seeing, see the data. They're actually using that bidirectional connection to get the data off of it, like what is the robot seeing off the LiDAR, what's the data you're streaming off of it as well, so you have a dashboard. Just kind of shows you, again, the power of cloud services that even you could be building or this community could be building to basically enhance what the robot does and how you interact with it. So this is something not coming from my team, but we're working closely with this group. All right. So where do we think the role of the cloud is, just to summarize this? You can use intelligent cloud services to enhance the local processing on the robot. And because you can actually improve performance over time, these services just keep getting better and your robot performance getting better without putting hardware or any processing on the software on the robot itself. You can use simulation to test your application and ensure that it's going to perform correctly under a wide range of applications, and do so at such low cost that you let your developers run these sims every time they try to check something into the code base. You can combine it with reinforcement learning to actually program for robot actuation and navigation. And again, many of these applications, other cloud services played a role in building the whole solution, and you didn't have to write a line of code. That's, again, where I think the value of the cloud is for the future of robotics. So I don't know where I am on time. Am I good? That's it. I'll open up for questions then also.
Any questions for Roger?
Yes, please.
Yeah, I think the simulation
Yeah.
question and comment based on feedback we received is how do you envision pulling the human back into the loop? So in manufacturing, perceived and pretend that a lot of it's science and physics based, there's still a lot of art involved. So pulling the tacit knowledge of the human in a different phase to communicate with the system.
Yes.
Becomes important. Where is that? Where do you
Yeah.
see that taking place?
Yeah, that's what I kind of liked about what AptPod was doing in terms of being able to put the human in direct control and interaction with the robot. Plus One is here today, although we're hearing a talk later today, they do something similar. To me, it should be a feature of fleet management. Right now, we're investing heavily in sim. We're going to start turning our attention, we're going to continue investing there. We're turning our attention to fleet management. That's where I see that kind of interactivity. I see it in security robots where basically they're patrolling when they see something of interest. On the fleet management, an alert comes up and the operator can take immediate control and see what's going on with that robot. So I do think that's kind of where it fits, and I hope we can learn more about that over time. Yeah.
Excellent. Thanks, Nate. Yeah. Roger?
Do you envision AWS taking over fleet management, development, and software control from the AMR companies?
Yeah. So the question was, do we see AWS taking over fleet management from the AMR companies? No, I don't. We actually think it's a complementary solution. I have enterprise customers who are not going to be able to hire all the necessary trained people to manage each one of these. Those people I can help and give them an offering and try to partner with AMR to say if there's some ability to interact with you or integrate with you, can we do that? And would that actually add value and allow you to actually invest where you think you need to invest? That's the approach we're taking here. Yes, please, Roger.
So in the traditional manufacturing environment, we have a lot of customers we work with that put nothing outside our firewall.
Yes.
So how do you deal with it?
Yeah. So the question was basically a lot of these manufacturers will not allow anything outside of their firewall. To be clear, I mean, if I step back, what I see is industrial robotics, I think they've got it. I think they've got everything well in hand. I'd like to see if we can help them in some way, but I think they've got it. We're actually seeing, look at the household cleaning robots. These are small startups. And this is what excites me. I want a 5-person startup team not to have to build a hardened version of ROS, but pick one up, have all the tools, go innovate, sell a robot, and they go international, and they can do so with our service. So that's where I see where we can add a lot of value, is these new innovative robots that are coming up. I think in industrial robotics, it's such a deep area. I think a lot of companies are already entrenched. No, stay there. Yeah, we're not trying to do anything. Yeah.
All right, one last one, and then we'll have to move on.
Please.
Right, so you said that you wanted the community to kind of follow what you did with the ROS build farm.
Yes.
Do you guys have documentation on how somebody could go about spinning their own build farm?
Yeah, but not just necessarily their own build farm, but basically integrity tests that basically all that software goes through. It could even be running on their PC, but wouldn't it be great if you knew that the nav package or some other piece of software that you're taking a dependency on, somebody hasn't checked some bad code into it, and you're going to spend weeks. You can actually see the tests that they've run, the date, the timestamp for those tests. We've been very open in the technical steering committee of ROS-I about what we've done and what tests we've run and what software packages we've used, and we'd encourage others to do the same thing. Let's start thinking. We actually have recently started with the technical steering committee putting quality grades on these software packages. So you should be able to look at those quality grades and go, okay, the community's actually stamped it with a quality score. This is where we want to get to. Let's make this the Linux of robotics, frankly, and the ecosystem as rich as we have today with file systems and other things. I think my time is up. Thank you, everyone, for your attention.
Roger, you'll be here tomorrow as well?